Hi students, today in this lecture we are discussing the topic is jet transform, that is jet transformation. So what is the definition of jet transform and where using the jet transform? So this is one of the transform techniques to finding the solution of difference equations. Okay na? So first of all in this lecture first we will discussing the definition and the basic formulas. Okay, so that is equal to see the definition here. So the jet transform of sequence un defined for discrete values n is equal to 0 comma 1 comma 2 up to so on, and un is equal to 0 for n less than 0 and n is negative value, un is 0, is denoted by z of un. So z is the capital Z is the operator, so and is defined as z of un, that is z transform of un is equal to summation n is equal to 0 to infinite un into z power minus n. So here z is a small z, this is a variable only. Okay na, because this is the un is the given sequence. So this is total series expand, the total term is in terms of z, so that value is assumption u of z or f of z. Okay, so that is where u of z or f of z is a function of z. So z transform is only apply for the sequence. So already we will discuss in the previous classes Laplace transformation. So Laplace transformation is defined for the function. Okay na, but z transform is defined for sequence. Okay na, so this is the definition of z transform of the given sequence un. See the note here. So yeah, Z transform exists only when the infinite series in. So this is the infinite series n. So this infinite series is convergent. So convergent means that is a finite value. Okay na? So this series value is always finite value. Then Z transform is exist. Okay. And Z transform is capital Z is the Z transform operator and the small z is the complex number, that is any number. So, and third one, the above Z transform is also called as one-sided Z transform. So, one-sided Z transform means, so n value n value is only defined for positive numbers, 0, 1, 2 up to so on. It is one-sided. The negative exists, but assumption for negative values un is equal to 0. So, the above sequence, the above Z transform is called one-sided Z transform or unilateral Z transform. And the another Z transform is Z of un is equal to summation n is equal to minus infinite to infinite. So, we assumption Z transform is starting from 0 to infinite. It is one-sided. So, here n is equal to minus infinite to plus infinite. Un into z power minus n is equal to u of z or f of z is called two-sided Z transform. And two-sided means n is the negative values and positive value. So that is called two-sided Z transform. But our syllabus is only one-sided. So this is a required definition of Z transform of given sequence. Okay. Yeah, next one, Z transform of some standard sequences, the basics form lesson. Yeah, first one. So if sequence a power n, then Z transform of a power n is equal to z by z minus a, where z greater than a and a is the any real number. Okay, now this is the first formula. Sequence is a power n. See the proof here. So assumption let the sequence un is equal to a power n. So by definition of Z transform, so assumption here un is equal to a power n, substituting here. So Z transform of a power n is equal to summation n is equal to 0 to infinite a power n into z power minus n. So now expand n is equal to 0, 1, 2, substitute here. So that is equal to n is equal to 0 and 1 plus n is equal to 1 a by z plus n is equal to a square by z square. So which form here? 1 plus a by z whole square plus up to, so which form? So 1 minus x power minus 1. So by definition of binomial theorem expansion and 1 minus x power minus 1 formula. Okay, now that is equal simplification is z by z minus a. So this is the z transform of sequence a power n is equal to z by z minus a. Okay. So a is any real number. Now substituting a value any number. So how to change the Z transform? See that. So that is equal to, so yeah, we know that formula here, substituting a is equal to 1. So Z transform of 1 is equal to Z by Z minus 1. If a is equal to minus 1, Z transform of minus 1 power n is equal to Z by Z plus 1. So similarly a is equal to 2. So Z transform of 2 power n is equal to Z by Z minus 2. So similarly Z is a is equal to minus 2. Z transform of minus 2 power n is equal to Z by Z plus 2. So up to so on, similarly we have to finding. Okay. So next one here, if sequence k is a constant sequence, so Z transform of k is equal to kz by z minus 1. Ikkada k is a constant sequence. So how to write the constant sequence k? That is k comma k comma k comma k up to so on. That is called a constant sequence. So therefore Z transform of constant sequence is equal to, this is the formula. Okay, now see the proof here. So assumption un, and un means nth term of the sequence. Un is equal to k, that is also sequence. So by definition is substituting here un place lo k, that is nth term here. Okay, Z transform of k is equal to summation n is equal to 0 to infinite k into z power minus n. So k is a common. Now substituting, expand the series. N is equal to 0 1 plus n is equal to 1 by z plus n is equal to 1 by z square plus up to so on. So which form here? 1 minus x power minus 1 form by expansion of the binomial theorem. Okay, that is equal to k into z by z minus 1. So this is the Z transform of constant sequence k. So kz by z minus 1. Okay. So next one of the recurrence formula. If sequence n power p is a sequence and p belongs to capital N. So p is any positive integer and p is equal to 1, 2, 3, 4 up to so on. Then Z transform of n power p is equal to minus z into d by dz of Z transform of n power p minus 1. This is one of the formula and we have to finding Z transform of n, Z transform of n square, Z transform of n cube. Then how to finding here using this formula. Okay, na? So minus z into d by dz of z power n, z of n power p minus 1. Okay. So by definition proofs here. So un place lo n power p minus 1 and okay na, but examination will not require the proof here. So I am telling here proof how to getting this formula. So un place lo n power p minus 1 and that is summation n is equal 0 to infinite n power p minus 1 into z power minus n. So that is equal to here, now differentiating with respect to z both sides. So that is equal to d by dz of z of n power p minus 1 is equal to summation n is equal 0 to infinite n power p minus 1. So z power minus differentiation minus n into z power minus n minus 1. So that is equal to minus z power minus 1 is a common. So remaining summation n is equal 0 to infinite n power p into z power minus n. See that this is the by definition of z transform. So un is equal here n power p. So that is equal to minus 1 by z into z transform of n power p. So therefore z transform of n power p is equal to minus 1 by z right outside. That is equal to z transform of n power p is equal to minus z into d by dz of z transform of n power p minus 1. So this is the proof of the recurrence formula. Okay. So see the example here. Find Z transform of n. Okay, n is the sequence. So let the sequence un is equal to n. So by using the recurrence formula, Z transform of n power p is equal to minus z into d by dz of Z transform of n power p minus 1. ఇక సబ్స్టిట్యూటింగ్ ఇక్కడ Z transform of n కదా అంటే n power 1 అంటే p is equal to 1 substituting here. So put p is equal to 1. So Z transform of n is equal to minus z into d by dz of Z transform of p is equal to 1 కదా అంటే n power 0. So n power 0 means 1. So already finding Z transform of 1 is a constant sequence 1, that is equal to formula Z by Z minus 1 only. So this is the formula, okay, minus z into d by dz of Z by Z minus 1. Now differentiation of Z by Z minus 1 minus z into, this is a differentiation Z minus 1 by u by v method. U by v method differentiation Z minus 1 minus Z by Z minus 1 whole square. Now simplification Z by Z minus 1 whole square. So therefore Z transform of sequence n is equal to Z by Z minus 1. Okay. So next one. Yeah, next linearity property of Z transform. So un and vn are two sequences and a and b are two constant. Then Z transform of a into un plus or minus bn is equal to the separating Z transform. Okay, now this is called linearity property. That is a into Z transform of un plus or minus b into Z transform of vn. Okay. So next one, Z transform of unit step sequence. So this is a definition of unit step sequence, that is equal to u of n is equal to unit step sequence only. So where u is equal to 0 for n less than 0. Okay, now when u of n is equal to 1 for n greater than or equal to 0. This is defined by unit step sequence. Now finding Z transform. So and its Z transform is given by Z transform of u of n is equal to summation n is equal to 0 to infinity u of n into Z power minus n. Okay, now so starting from n is equal to 0 and n is equal to 0 means 0 to 1 2 3 4 always the value is 1. See, the negative value is no required. So n greater than or equal to 0 means for n is equal to 0 1 2 3 4 up to so the value is 1. So that is expands here 1 plus 1 by z plus 1 by z square plus up to so on. So which is equal to 1 minus 1 by z power minus 1. That is by using expansion of binomial theorem. So that is equal to Z by Z minus 1. So this is the Z by Z minus 1 is the Z transform of unit step sequence. Okay. So next one. So Z transform of unit impulse sequence. So this is the definition of unit impulse sequence is denoted by delta of n, that is equal to 1 for n is equal to 0 and where n is equal to 0 the delta of n is equal to 1. Okay, now for n is not equal to 0 the value is 0. Okay, now so now finding the Z transform here. So Z transform of delta of n is equal to summation n is equal to 0 to infinite. So delta of n into Z power minus n, that is equal to here n is equal to 0. N is equal to 0 అయినప్పుడు unit step sequence is only 1. అవునా, నెక్స్ట్ n is equal 1 అయినప్పుడు 0. ఇక్కడ చూడండి n is not equal 0 కదా అంటే for n is equal 1 n is equal 2 n is equal 3 up to so on, then delta of n is equal to 0. So first term only 1 plus 0 plus 0 plus 0 plus up to so on, that is equal to 1. So therefore Z transform of unit impulse sequence is equal to 1. Okay. So this is the Z transform of the sequence basic definitions and basic formulas. Okay. For more videos please do subscribe my channel, like and share it. Thank you.